Welcome to a video lesson on the applications of trigonometric equations, and our goal is to solve application problems. So here we have a function that models the average monthly temperature of the water in a mountain stream, where T of x is the temperature in Fahrenheit of the water in the month x, where x equals 1 is January, x equals 2 would be February, and so on. So we have two questions here. What is the temperature of the water in October? Well, October would be the 10th month of the year, so it's pretty straightforward here. We have to replace x with 10 and evaluate this function. Let's go ahead and do that. So pi over 6 times 10 minus pi over 2, and then we'll add 53 to that. So let's go ahead and get our calculator out, and we'll make sure we're in radian mode. And the reason I know that is pi over 6 and pi over 2. So we're just going to type this in and see what the temperature would be. And it was plus 53. So it looks like in October the water temperature is approximately 43.5 degrees Fahrenheit. So that's a pretty straightforward question. Now the next one says, what 2 months are likely to give a temperature of 62.4 degrees? Let's take this on the next screen and see if we can solve that. So now they're giving us the temperature, or T of x, and they want us to find the possible values of x, or in which months the temperature will be 62.4 degrees. Let's go ahead and set this up. So let's go ahead and isolate the sine function. So we'll subtract 53 on both sides. That'll give us 11.2. Now we'll divide by 19. This comes out to approximately 0.4947. Now what we can do is take the inverse sine of both sides. So on the left, we have the inverse sine of 0.4947 equals inverse sine of this quantity will give us just this quantity. Let's go to the calculator and evaluate this. Inverse sine 0.4947. This is going to give us an angle of approximately 0.5175 radians. But remember, the sine function is also positive in the second quadrant. So there's going to be a second angle here that has a sine function value of 0.4947. So even though it's not in the range of inverse sine, the original equation does not have inverse sine in it. So we are going to have to find that other angle. So we found this angle over here, but we need to find angle in the second quadrant that has the same reference angle. So this angle is going to be pi minus 0.5175, which comes out to approximately 2.6241. So we actually have two equations that we have to solve. Let's go ahead and take this information onto the next screen. We're going to set the right side equal to 0.5175, and then we'll take the right side and set it equal to 2.6241 as well. Again, we had two different angles that had the sine function value that we were looking for. We had this, and we also had this angle. So in order to solve this for x, we'll add pi over 2 to both sides. Let's go ahead and do the same thing on this side. This will be approximately 2.0883 equals pi over 6x. And on this side, we're going to have 4.1949 equals pi over 6x. Now we'll multiply by the reciprocal, or multiply by 6 over pi. So this simplifies nicely, and we're left with x is approximately equal to 3.9884. And over here, we'll have x is approximately 8.0117. So this is very close to 4, which would be April. And this is very close to 8, which would be August. So these would be the 2 months where we'd expect the water temperature to be 62.4 degrees. So it's a little involved. So we have to be sure when we use inverse sine that even though the second value is not in the range of this inverse function was not in the original equation, so we do have to find that second angle. Let's go and take a look at one more question. Raoul's heating oil is very seasonal, with sales in the winter far exceeding sales in the summer. Monthly sales can be modeled by this function, where S of x is the average monthly sales in the month X, where x equals 1 is January, and so on. So the first question, what is the monthly average sales in July? Well, July is the 7th month, so we have x equals 7. So just as before, we'll just replace x with 7. We just did one like this, so I won't take the time to type it into the calculator. It comes out to approximately $3,554.52. Okay, for the next part, for what months of the year are sales less than $4,000? I think what we'll do this time is look at this graphically. So we'll graph this function and determine for which x values it's below the line y equals 4,000. So let's get our graphing calculators out. Make sure we're in radian mode. Next, let's set up the window so we get a nice view. And I've already set it up nicely. X goes from -1 to 13 by ones. Remember, x is the month. Y is the dollar value of sales, and I set it up from -200 to 8,000. I like to show negative values here so we can see the origin on the coordinate plane, and we'll go by 500s. Next, I already typed in the function into y1, and then in y2 we're going to type in $4,000 because we want to know in which months the sales are less than $4,000. So we want to see when y1 is below y2. If we press graph, you get a nice visual of how the sales are high in the beginning of the year, they go down in the summer, and then back up in the fall and winter. The sales would be below $4,000 in this interval here. So we need to determine what the x value is here and what the x value is here. If we press second trace, option 5 for intersection, and scroll over to the left, it only finds one point of intersection at a time. Let's press enter 3 times. So x is approximately 4.94. Let's go ahead and record that. So if x is greater than 4.94, and let's go ahead and find the second point of intersection. Scroll over to the right, press enter 3 times. This value is approximately x equals 8.05. So when x is between 4.94 and 8.05, the sales are below $4,000. Well, this is very close to the 5th month, which would be May, and the 8th month would be August. The sales would be less than $4,000. Now, one thing we have to be careful about here, some textbooks are very technical. If we say x equals 8 is August, then that means from 7 to 8 would be August. Anything larger than 8 would actually fall into the next month or September. You can see I'm rounding to the nearest month. So this is close enough to 5 for me, and this is close enough to 8. Therefore, we'll say between May and August. I hope you found this video helpful. Thank you and have a good day.